Hello there, Math 8. This is Mr. Bainey. We're going to be looking at review stuff for Module 3 and Module 4 to help prepare you for your test that's coming up shortly. This first page is page 91. It should be in your binder, page 91. If you also do not have a calculator, um, please have one out. I have some calculators. If you'd like to borrow those, you are allowed to use them for your test. So go ahead and do that right now. You're also going to be pausing this video every couple of problems, just so you can kind of keep up with the solutions here. We can kind of move at a nice pace. Make sure you're focused. You're trying to prepare as best you can. If you are wanting to just move ahead and work ahead of this video, that's totally fine. You can also help people around you, explain things to them, teach them if you have to. So here we go. 3.1, number 1 and number 2. I'm going to give you a couple hints here. Proportional relationships was first introduced in this lesson, and if you recall, our general form of an equation, a proportional relationship, is y equals kx, and we're going to be doing k is equal to y over x. So if you have not tried these problems yet, then go ahead and pause it, and then wait about 3 or 4 minutes for everybody to try it out, and then continue the video. So as you can see underneath the table, I'm doing y divided by x. So it's 3 divided by 2 for the first pair, 4.5 divided by 3. I'm going to do 6 divided by 4, and 7.5 divided by 5. Use your calculator for this. It's I think much easier and faster, and you don't have to worry about getting these wrong. Use your calculator. But 3 divided by 2 and all of the other fractions that you do there in the calculator is going to give you a constant of proportionality of 1.5. So that's the answer. Number 2, Phil is riding his bike. He rides 25 miles in 2 hours, 37.5 miles in 3 hours, and so on. Find the constant of proportionality, write an equation to describe the situation. So we have to do two things. We have to find the constant of proportionality first, and then write the equation. But anyway, to write the equation, we need to know that constant of proportionality anyway. So k is going to equal, we have to know what y and x are, and so it's not completely obvious here. But x is usually going to be the time, the hours, and y is our miles. So we're doing 25 miles divided by 2 hours, and that's going to give us 12.5. If I did 37 divided by 3 here, or 50 divided by 4, I still get 12.5. So it's going to be the same regardless of what you do. So our equation is y equals kx, or y equals 12.5x. So here's our equation. Here's our constant of proportionality. And we're done. Okay, go ahead and pause the video for this one. Number 3 and number 4. Take about 2 or 3 minutes to do this one before you continue. And as a hint, you can use rise over run between 2 points to find the slope. Okay. So on number 3, here's 2 nice points. 2 of them. Another nice point is way down here. Well, not way down here, but right there, that third one if you like. So if I start at 1 point, let's say I start at the origin, I want to do rise divided by run, or rise over run. So my rise is I went up 3, and my run is I went over 1. So my slope, which I use m for, is 3 over 1 or 3. I accept either one, 3 over 1 or 3 are both acceptable. Number 4, here's a point at the origin, and at the bottom there and at the top are some nice points. A little bit harder to see, so number 4 is a little bit trickier. But if I start at the origin, I do a rise of going down and going over. I could also do up and to the left, and I'm going to get the same answer. So know that there are other ways to do rise and run, but you should arrive at the same answer regardless. So I went down 5, which means it's -5, and then I went over to the right 1, that's positive. our slope in this case is going to be -5 over 1, which is the same as -5. I accept both of those answers. Okay, and go ahead and take a few minutes to try number 5. Just to clarify this problem, we have train A travels at this relationship using that equation, I guess. And that means that the distance is equal to 70 times the time. 70 is the kilometers per hour. It's the rate or the speed. So that means that in 1 hour, the train goes 70 kilometers. I'm sorry. In 2 hours, it's going to be 70 times 2, which is 140. All right, so let me go ahead and I'll write down a table here. So if the time is 1 hour, the distance is 70 kilometers. If the time is 2 hours, the distance of this train is 140 kilometers. And in 3 hours, it's 210 kilometers. Okay, so that's train A. And then train B is represented by the table. It tells you in the problem that train B at various times, so we got times of 2 hours, 4 hours, and 5 hours, and how far it goes. So your task here is to find the unit rate of each train and which train is going faster. Okay, go ahead and pause it while you take, since I gave you some really good hints there. Pause it for a couple minutes and continue for the solution. Train A is 70 kilometers per hour, and train B, I'm just going to do a, let's see, I'm going to do y divided by x. I want to see if this will give me a proportional relationship, because if I do 150 divided by 2, and I did 300 divided by 4, or 375 divided by 5, you'll want to check all of them, and you won't see me doing it, but I'm going to be putting this into my calculator to see what I get for all of those. And it looks like I get 75 every single time. So 150 divided by 2 is 75. This gives me 75, and this gives me 75 if I use my calculator. So that means, since it's proportional and I get the same thing, that 75 is my unit rate. And by the way, when I ask for unit rate, it has to have these units. Okay, this means kilometers per hour. Okay, it's y divided by x, or y per x. If A is going at 70 kilometers per hour and B is 75 kilometers per hour, then that means B is faster. Okay, it has the faster unit rate, the faster speed. Okay, let's look at the next page. So if you don't have it out already, go to page 123 for Module 4 practice. 123. And go ahead and take a few minutes to work on number 1, number 2. Here's some hints. On number 1, you're going to be substituting in the x numbers, the x values. So you're doing y equals 3 times x plus 2. So instead of x, you're going to be putting in these numbers that you see in the table. So if x is -1, then you're doing 3 times -1 plus 2. Okay? So go ahead and pause this video before I start inputting some of these solutions. Okay, if y equals 3 times -1 plus 2, 3 times -1 is -3. -3 plus 2 is -1. I'm not going to show the work for every single one of these. I'm just going to do it for the first couple. So if x is 0, 3 times 0 plus 2 is 0 plus 2, which is 2. Okay, 3 times 1 and then plus 2 is 5. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. Okay, and so that's how I get all that. If you only write numbers in this table. I know that many of you might be using your calculators, which I allow, and it's totally fine. But this work that you're showing here is going to ensure that you're at least getting some of that partial credit. If you make a mistake here, and I don't see any work, I have no idea what it is you're thinking or what you're doing, or if you're just guessing. I don't know what's going through your mind. So I want to be able to give you some of that credit you deserve if you are doing some correct thinking. Okay, so keep that in mind. Number 2, we're going to find the slope and the y-intercept of the graph. The slope is our rise over run. Okay, remember we did that on the previous page, on page 91. The y-intercept is where it crosses the y-axis. So that one should be the easiest one to get, but if I look at where does my blue line cross the y-axis, it's right there. And if I look for some more nice points, I got one there and I got one here. Doesn't matter, I just need 2. So y-intercept is 0, 1. Or I could just say it's 1, right? It's at 1 on the y-axis. My slope is I'm going to rise that much and I'm going to run that much. Okay, so let's write these down. My slope is 3 over 1, or 3, same thing. And my y-intercept is 1. Or I could write it as 0, 1 if I wanted to. Okay, I accept both of those as well. All right, the next couple problems. In fact, let's go ahead and take about 5 minutes and do the rest of these, 3 through 6. Number 5 and number 6 have to do with 3 and 4 anyway. So pause it if you have not tried these yet. Okay, number 3, graph the equation y equals 2x minus 3. We're going to compare this to y equals mx plus b, because that's going to help us determine our slope and our y-intercept. Remember that our slope is m, so it's 2, and our y-intercept is negative 3. Okay, so I'm going to write those down. M is 2, y-intercept is negative 3. So I start at negative 3. There it is. Let me zoom in a little bit. Negative 3. And my slope is rise 2 and run 1. So you see here on the left side, I actually changed my 2 to a fraction. I'm going to rise 2 and run 1. And there's my second point. So I can now connect these points to make my line, and I'm done. Number 4, does the table represent a proportional or a non-proportional linear relationship? I can do so by, remember, doing y divided by x. So 4 divided by 1, 8 divided by 2, 12. You have to check all of them. Remember, I've said this before. You have to check all of them. Do all of these give you 4? Because I know the first one does, that one does, third one does. Yeah, it looks like they all do. So this is proportional and linear, proportional linear relationship. Number 5, does the graph in exercise 2 represent a proportional or a non-proportional linear relationship? And then number 6 asks, does the one in exercise 3 represent proportional, non-proportional? So I'm just going to zoom in here and we're going to write it right next to it. So number 2 is the top one. You want to think, is it proportional or not? And it's based on what b is. If b is 0, that's the y-intercept, it's proportional. If it's not 0, it's non-proportional. So b in this case is 1, so that means non-proportional. And for number 3, b is negative 3, so that one is also non-proportional. Remember, if b is 0, it is proportional. Okay, and that's it for the review. Remember that you can use a calculator for the test. If you're going to use your whiteboard, then make sure you are only using the graph, the page that has the graph on the whole side. Okay, good luck on the test. Have a great day.